हाय गाइस। सो लास्ट टाइम हमने बात करी थी, वी टॉक्ड अ लॉट लास्ट टाइम। जस्ट शो यू इफ आई हैव एनीथिंग हियर राइट नाउ। सो लास्ट टाइम हमने बात करी थी कि कैसे हम वाई एक्सिस पे ऑर्डर मेंटेन करने वाले हैं। एंड ऑल्सो टॉक्ड अबाउट कि कैसे हम कॉलम्स के ऊपर इटरेट करके फाइंड आउट करते हैं कि कौन सी कॉलम अवेलेबल है, एंड सो ऑन एंड सो फोर्थ। राइट, वी सॉ व्हाट काइंड ऑफ कोड डिड आई राइट, एंड एट द नेक्स्ट वीडियो वी आर गोइंग टू सी कि हाउ इज इट परफॉर्मिंग. Turns out it wasn't performing that good. So I did certain changes that would make things much more easier. It's like the classical problem कि you over engineer things. वही problem हुआ है. For some reason JSON was still going very very fast and I did not understand why it was going until I did understand why it was going. I will just show you मैंने क्या changes करा. तो you will see I'm still taking the idea is still the same कि we are going to create a table. We are going to have the buffers and all of those stuff. But this time access पे there is no order going to be maintained. So this is the older code जहाँ पर हम order maintain कर रहे थे and everything. Here I did a little bit change कि gases के लिए मैं सारे indexes mapping करके रख रहा था कि ये gas का index क्या है. That way every time मैं loop में जाकर चेक कर रहा था कि ये gas कहाँ पर available है. I was thinking that it would be okay, but when you're talking about millions of data points, it is not okay. And most of my time I'm only trying to load the data from database and maybe doing one or two operations on the data and then just sending the data to the client or maybe processing the data for creating a report or something. So most of the time I'm just reading the data, but actually I'm not reading the data, I'm just sending the data most of the time. So order does not matter there. Wherever the reading the data is happening, there order matters. Most of my operations are just loading the data. In other words, when database is giving me a bunch of rows, I want to load it as efficiently as possible. If there are millions of data points, I want to load them in the most optimal way. That was the goal. And when I was doing this kind of thing कि जहाँ पर हर बार ऐसा होता है तो फिर I have to always shift the row little bit. So मैं ऐसे भी लास्ट टाइम हमने जब बात करी थी there was a case कि यहाँ पर कुछ rows empty है, so we can utilize those rows. But turns out it was going slow. So मैंने एक और optimization डाल दिया कि let's just assume सारे rows एक साथ हो गए, नीचे only in the bottom section there will be the empty rows. It was still getting slow. Then I added an optimization कि यहाँ पर हर बार loop के अंदर जाने के बाद like CO2 कौन से column है, कौन सा column ID है उसका, CO2 is CO2 in the first column or second column. I have to check it for every single row, and that was becoming a little slow. So I did a hash map for that. That made things faster. Like that, there were few optimizations. You will be shocked to know that now I'm no longer maintaining the order on the y-axis because that was also one thing that was making things really, really slow. There was one advantage over JSON, which was always there, which is when I was trying to load like more than 1 million data points with 30 columns in each table, then I was always getting a JSON error that memory out of like memory leaking. I will show you what kind of error it is. But अपने buffer वाले केस के अंदर कभी memory leak नहीं होती थी. So that is the awesome thing. But it was very painfully slow. Like 1 million data points के लिए भी वो बहुत slow था. It was 8 times slower than JSON. So it was unbearable. So finally मैं अभी जो current है, which is the most efficient and the correct one, which is like faster than JSON also. So in this case, what we are doing is very simple. You will see I'm maintaining certain things, which columns and which rows are available to use, and ये epoch का रो इंडेक्स क्या है, ये गैस का कॉलम इंडेक्स क्या है, ये लेबल का कॉलम इंडेक्स क्या है. वी आर मेंटेनिंग दिस. So now you see it has become really really simple. Like पहले I have to figure out. I also added the optimization when I was ordering the y-axis. I also added the optimization of binary search. Maybe that would help me, but it did not. So finally, it turns out that every time I was shifting these rows, that was very very painful. That was a very expensive task. Yes, very very expensive thing. Even though it is working on C++, still it is very expensive to do. That's why to skip that we did this. So basically, we don't care about the order anymore. Right? Initially, everything is 0, 0, 0. So all of these are going to be free rows and free columns and everything is free. As soon as the first data point comes, we check, we pop one of the row from here. So we just get one. So यहाँ पर जो free का हमने यहाँ पर जो array बना के रखा है उसमें से बस एक element अपन pop कर लेता है. That is it. That is how we are working with. Anytime there is no longer rows available, we just add bunch of data here. Yes, in that operation still takes place with copying the data. So that is still expensive. But the idea is that wherever I'm trying to load the data, I probably know how much data do I want to load. Like if I have a query that I want 1 million data points, then I literally know how much data or how much size of my buffer is going to be. So idea is that changing the structure of table is not going to happen that much. Right? Before even loading the data, I'm going to know how much data I want, how much space do I want, how much memory do I want. So that is not going to be an issue for us. So restructuring is not going to be a problem. But even if we do have to restructure, it is very simple. We just copy all the data in the bigger data set, and newer rows and newer columns that we added, we just add it to this particular array, and we work as it is. I will just show you. So before, all of these functions had a loop in them. Now they don't. That is very good. Then when you want to get a time, now you can pass in what you want to do. Do you want in ascending order, descending order, or do you just want the data? You don't care about the order anymore. So in that case, we can do this kind of thing. This is a little optimization. In case if you want to do ascending or descending, we just take all the data and then sort them and then yield. So that way you can get an order. Simple. Then if you want to get the time index, it is very simple now since we already have all the indexes memoed. Then if you want to add a time, again, it is very simple. You just check if already this time exists. If it does, you just return that index. If it does not, then you just check if there is free space available. If there is not, then just we create new tables and we set all the, copy all the content to those new tables with bigger sizes. And then we simply just add all those in new rows to the free index. And then we reassign all the variables. And then we just pop one of the element from the free. And then if we still cannot pop any element, then we just throw an error, no space found. And finally, we just assign and we are done. Removing a row is also very simple. We just remove it from this. Okay, yes, we can also add it here. Right? Push ti. We could push it for that this is now available. and we empty out all those content from the table. Then similarly for gas, we don't care about the order there anymore, so we never actually cared about the order in gases. So there it is. Similarly for getting the index, same thing for adding the index. We saw last time how to add space in gases columns. If we lack space in gas columns, then how to add it. We have saw that last time. This is that exact code, and then we just do this much. Removing is also very simple. Here also we can do this dot free gi dot push gi. Most of the time we are never going to do remove and all these operations, so this don't matter to us that much. These are only done to delete, but there is no point in doing this. Nobody is going to, none of my code is going to utilize or leverage this particular piece of line. So it won't matter to me, but I'm still writing it because it is correct thing to do. Anyways, label के अंदर भी वही चीज़ हो रही है. We already know how label and cases work the same. Then getting a JSON is also again very simple. If you want to get a JSON, just do this. Getting concentration is again also simple. Setting the concentration and all of those things are again also simple. You will see that जो मैंने last time थोड़े से asserts डाले थे कि if this is not right, like TI is invalid type of values, then we want to throw an error, but I let it be. Let the bug happen because like I'm assuming whenever I'm going to code thoroughly, and it's not like I'm going to push such random code in production, so it won't be an issue for me. Yes, so importing data points is again also very simple. We can look at it now. But the idea is, see, we thought about how we can do importing from data points to buffer, but turns out I will never have to use this because from see data point was my defined structure, our defined structure. Database में तो ऐसा structure नहीं होता, database में तो अलग structure होता है. So we have created a different architecture for it. We are directly going to use the set label and set concentration when interacting with database. I will just show you. I have created a mock database for us, so I will show you from that. Similarly, export is very also simple. Compressing is the same code. We don't really did that many changes. From buffer is also very similar. To buffer is also similar. Encoding and decoding to base64. So we just take buffer first and then encode it to base64. Same thing for decoding from to base64. Great. Now, first I will show you function test. So this is just a way to check if functionality works or not. So what I'm doing, just created a utility function, then array buffer check. This is also a utility function. This is our JSON, very simple looking JSON. This is how our data points are going to be. And then we are using this JSON to interact with our thing, our buffer. Let's do that. पहले issue आ गया bro. Let me just copy my data set. Where is it? Oops. Will this work? It did work. It is the same code, but just with little bit changes. Yes, unknown order. Right, right. Where is the functionality test? Yes. So here now I have to define take this kind of changes. यहाँ पे पहले default value मैं descending ले लेता था, but now I've made it compulsory to give. Just pass descending, descending. Let's just see now. This was the original JSON, which got converted to buffer. We have memoized all those timestamps and guesses and labels and everything. We have this many free indexes left. Then these are label mapping. We have times. Then we have guesses and label column. So most of those columns are empty. Just last three columns are filled. Last two columns are filled. We don't really care about the order, so let it be. Values are there. Yes. And in case of time, so we have 150 buffer points. Yes, that is because these are 30 and this is 5. So yes, 150. Then we convert it back to JSON. Then we try to get times in order, guesses in order. Then we got labels. Then we've got O2's index, H2O's index, which is -1 because it does not exist. Sim's label index, which does not exist, so it is -1. Locations index, which does exist and it is 9. Get gas concentration, so that is also correct. SO2 concentration, so for in the third JSON, 0, 1, 2, 3, third JSON, SO2. Okay, so we will have to look. So here, when I'm converting back to JSON, even though these two keys never existed in the original one, see 0, 1, 2, 3, here only CO2 existed. And it gave me all those keys, even ones that did not exist, so we will have to update that. 2 JSON, 2 JSON, export data point. Yes, so it is just taking the JSON one. Yes. Here we are not doing anything, that is the issue. Here if con equals 0, here if con should not be equal to 0, only then do this. Here if LVI should not equal to 0, only then do this. Correct. This will fix our issue. Yes. Now we converted back to JSON. This time it did not give us the non-existing value, which is great. Yes, so here it tells us that in the third index, SO2 does not exist. Same thing. Okay, while setting the buffer, it gives us this. We have printed that. Again, we have printed this only. And then gas concentration. We are setting it back. We are deleting all those locations. We can just do one thing. In this functions, let's just leave it. Then we added certain times, added gases. So every time we add something, it returns us the index of where it has stored it. A little hint. Now we have again removed those things. Now we have compressed it. And now we are checking whether new equals old or not, which it does not. And then we are finally done. Okay, we converted back from buffer to the data point. So all those functions actually work, which is great. We have to still check one thing here. Why is old not equal to new? So basically, wait, why would old not equal to new? Hmm. Let's not do anything, any of those consoles. And after that, I'm adding a time, then added a gas, added labels, right? Then removed all those gas columns, removed those newly created labels, and then removed the time also. We can also do that update here. Remove label, this dot, reali dot push, li, this dot, retime dot push, pi, this dot. Then we compressed all of those things. We just need to check if those JSON versions actually are true or not. We don't care about the buffer part because now we don't care about the order. We don't care about most of the things. So this might be false, which is probably going to be true. But is their JSON version true or not? Create a function. Yes. Perfect. In descending order, after doing all of those things, new JSON equals data compact dot export data points descending buffer JSON JSON equal old JSON new JSON. Okay, let's check this. So this is also not equal. That is an issue. So that's all. Old JSON, new JSON. What changed? So new JSON, none of the data actually came through. This is probably because did not change anything in the compact version. When doing the compress, take the length buffer. Okay. Object timestamp. Wherever the time is not equal to this. Well, instead of this bullshit, we could also do let x equals 0. Memo ti and time comma ti. Then x equals 0. Const gas comma gi of us dot memo gi. Again x equals 0. On global ls of us dot where it is memo li. Now memo के अंदर जो सारे valid ही हो गए, so we don't have to check this. We don't have to do this also. Guess maybe. Then we just copied all those labels. We did a reverse mapping of those labels. Yeah, that is fine. Then what did we do here?